All right, we are continuing with our big idea. Knowing what numbers mean helps us to compare things and to solve problems. And today we're talking about fraction and decimal benchmarks. We can use benchmarks to compare and order decimals. So that's our real goal here, is to compare and order decimals, determine which decimal is largest or smallest. And we can think about our benchmarks of 0, half, and 1 in decimal form. So 0 half now becomes 0.5 and 1 becomes 1.0. So if we were comparing these two numbers, which decimal is greater, 0.25 or 0.7? Well, 0.25 is between 0 and half, whereas 0.7 is between half and 1. Therefore, we know that 0.7 or 7/10 is larger. The other thing we can do is we can make them into equivalent decimals, and this I personally find to be the most effective. So equivalent decimals. And all that means is that you are adding a 0 to the end of your number, and then you're comparing them exactly the same. So 0.7, it's a little hard to compare to 0.25 because here we have two digits. If we add a 0 onto the end, we can easily compare 70 to 25 and see that 70 is in fact larger. We haven't changed the value because remember when we were looking at decimals, 7/10 and 70/100 is exactly the same amount. It's just like saying we're taking that one row that was a tenth and making it into 10 little bits, so we have 100th flat to use there. So equivalent decimals really helps when we're comparing. So here we go. We're going to put this into practice. We are ordering 0.7, 0.9, and 0.32 from least to greatest. And here they've made their decimal benchmarks again. 0.00 for 0, half 0.50. Again, remember those are exactly the same, doesn't change anything. 0.70, 0.90, and 1 with the two zeros on the end. Makes it really easy to compare 32 to 70 to 90. We know that this is the smallest fraction, this is the middle fraction, and this is the largest fraction. Decimal, sorry. Smallest decimal, middle decimal, and largest decimal. My mistake. All right, now you're going to do some practice. You're going to compare and order from least to greatest the following sets. So for A, 0.5 compared to 0.46 compared to 0.02. You can use decimal benchmarks, you can use equivalent decimals. It's up to you how you want to do that. B, 3/4. So 3/4 written like that, and you'll often see it like that in your books, actually means 3/4. So as a fraction, compare that to 0.7 or 7/10 and 0.67 or 67/100. And then lastly 0.38 with 0.9 and 0.89. Or again 0 and 89/100 if you say it the proper decimal way. So go ahead and press pause and try these on your paper and we'll review them in a moment. Alright, so let's take a look. Oops, sorry, don't have my pen working here. A, we had 0.5, we had 0.46, and we had 0.02. Now I'm going to use equivalent decimals. I'm going to add a 0 on there, and now I can quickly compare. Is 50 more, is 46 more, or is 2 more? Well, that would mean that 0.02 is the least, 0.46 is next, and 0.5 is greatest. Because adding that 0, we can easily compare 50 to 46 to 2. Alright, let's take a look at the next one. We had 3/4, 0.7 or 7/10, and 0.67, 67/10. 67/100. Now again, I'm going to use equivalent decimals. I'm going to add that 0 on there to make that 70. I can now compare 67 and 70, but 3/4 is still not comparable. When we compare things, we want to make them as much the same as possible. So what we need to do is take 3/4 and put it into a decimal. So these are all out of hundreds. I'm going to see if I can make this out of hundreds. 4 times what is out of 100? Well, 4 times 25 would make 100, so 3 times 25, 25 is also going to work, so 75. So that would make this 0.75. Now I can very easily compare those. 0.67 is smallest, 0.77 just on its own is next, and then 0.75, which is actually 3/4, is next. So that's how we would compare those. All right, lastly, 0.38, 0.9, and 0.89. Again, I'm going to make that into equivalent decimals, so it's easy to compare. I can now easily compare 0.38 is smallest, 0.89 is next, and 0.9 is largest. Now, I just had a thought as I was looking at the other fraction one and changing it into a decimal. Sometimes changing a fraction into a decimal is very hard to do when it's an equivalent fraction. So say for example this was I don't know, 9 on the bottom. Okay, let's make this into 3/9. Just a sec. Alright, let's start fresh here. Say I had 3/9. Well, there's nothing I can multiply with 9 to make 100. There's nothing I can multiply with 9 to make 10. So then I have to use a different strategy in order to make it into a decimal. I then need to, I can divide or cross multiply. So I can go 3 times 100, which equals 300, and then I divide by the bottom number, so I divide by 9. 300 divided by 9, and you're going to need to use your calculator very likely for these because they're not working as they would if it was just an equivalent fraction, which sometimes happens. So 300 divided by 9 would be 33.3333333, and in that case you would just round yours to 33. So it would be 33 or 0.33. If you wanted to make it into a percentage, it would be 33%. So we should try a couple of those because I'm not sure we've had some time to practice those. So let me just write a few for you. 1 second. Alright, so you're going to try to turn these into decimals, and none of these work very well using equivalent fractions, so you're going to have to use the cross multiplying strategy. So remember, it's 100 on the side here, and it is multiplying across, and then whatever your answer is, it's dividing it. So go ahead and press pause and try those 3 now. Alright, so again, you will need to have your calculator handy for these because it is a little bit tricky. You won't be able to necessarily do this in your head. So again, I'm going to go 6 times 100, which is 600. That part's easy enough, annexing 0. But it's the 600 divided by 7 part that gets tricky. Divided by 7 equals, and it actually equals a decimal number, of 85.7 blah 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 blah, and it continues, but I'm going to use this to round, and we use our same old rounding rule. Look right next door. 7 tells us it needs to round up, so that would be 86 over 100 then, which means as a decimal number it would have to become 0.86 for this one. Okay, now let's try 8/15. I'm going to just divide my work there, and again I need to have my 100 here, and I'm going to cross multiply. 8 times 100, which is 800. 800 now divided by 15, and I'm going to need my calculator for that. My answer ends up being 53.33333. I'm going to round, look right next door, it stays the same, so it's going to become 53 out of 100. So as a decimal number, then it's going to become 0.53. Okay, try the same thing for 4 and 13, and I'll just change my color again so that it's easier to know what goes with what. 4 times 100 is easy, 400. I now have to divide that by 13. That's where it gets tricky. I need my calculator. 400 divided by 13 is 30.769, blah, 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 and it continues. I just look at my 7. 30 to 7 means that's going to be 31. So as a decimal number, it would be 0.31. All right, just so you've had some practice with that as well. Because sometimes it doesn't always work just to make it an equivalent fraction. All right, now you are moving on to your concept practice. Page 181, 182, numbers 2, 3, 5, 6, and 8. You are comparing and ordering fractions and decimals. It again suggests using benchmarks. It's up to you what strategy you prefer. Use whatever works best for you. And again, as you work, make sure if you have questions, you let me know. And again, here are your textbook pages, since many of you seem to be forgetting your textbooks an awful lot. I've added this now to our videos. So here's your first textbook page, part of your second textbook page, and your last few questions. Make sure you complete all the questions that were asked for. Do the best that you can do. Remember to complete all parts of the question. If there's an explanation, you are expected to use sentences. If you have questions along the way, let me know. Good luck.